Hi, welcome to the new edition of Admiral Science. As you can see, Admiral Science has a new look to it. Hope you guys enjoy it. Well, let's get this show started. Alright, today on Admiral Science, we're back, and today we're talking about tides and seasons. So let's start off. What is a tide? Well, tides are your daily changes in the level of the ocean water. And so tides are caused by the difference in the gravitational force of the sun and the moon. So it's basically like they're competing with the water, so who can have the strongest gravitational pull. So on one side, you'll have the moon pulling all the water towards it. On the other side, you have the sun pulling all the water towards it. And so when they pull it, you get a high tide on their ends, and then a low tide on the opposite sides. So here if our picture is anything like what we want to see, the low tides, as you can see, are at the top and at the bottom, and our high tides are on the sides where the sun and the moon are located at. So they both play an important role in our tides. Alright, and then we have our seasons, and if we can remember about revolution and rotation, revolution is when the object goes around another object, and rotation is when the object just simply spins. And so the Earth revolves around the sun and rotates on its axis. And so the revolutions gives us our seasons, and the rotations gives us our night and day. So what type of path do planets like to take around the orbit around the sun? They like to take these elliptical paths. They're not quite circular. They're more of an oval shape. At one point they're closer to the sun, and at other points they're further away from the sun. So what causes the seasons? There are two factors. One is the Earth's tilt. The Earth is tilted at 23.5 degrees. The Earth's axis always points toward the North Star. So there are times when the Earth is tilted toward the sun, and there are times when the Earth is tilted away from the sun. And that tilt lets you know who's in what season. And also the Earth's spherical shape. The sun's rays hit the Earth differently depending on its location. So towards the equator, their temperature typically stays the same throughout the year because they're always getting that direct sunlight coming through. Alright, whereas the northern and southern hemispheres, they're as well as the northern and southern hemisphere, their light will vary depending on if the Earth is tilted toward the sunlight, or if the Earth is tilted toward the sun, or if the Earth is tilted away from the sun. So here we have our Earth seasons. As you can see, when the Earth is tilted toward the sun, the northern hemisphere is experiencing summer. When the Earth is tilted away from the sun, that northern hemisphere is experiencing winter. And whatever the northern hemisphere is experiencing, the southern hemisphere is experiencing the opposite. So when we're in winter, us over here in North America, when we're in winter, the southern hemisphere is in summer, and when we're in summer, the southern hemisphere is then in winter. And same thing goes for the spring. Alright, and then when the Earth is actually closest to the sun is our mid-seasons. So the autumn is on one side and the spring is on the other, and that's when we're closer. Our more extreme seasons like winter and summer is when we're actually further away from the sun. And there you have tides and seasons. Hope you like the new look of Admiral Science. I love Prezi, and from now on it looks like this is the route I will be taking. Enjoy. If you have any questions, please leave a comment. I hope to see you guys later.